2.2, we were doing operations with functions. So we learned how to add, subtract, multiply, divide to make new functions. And so sometimes that's all they want. They just want the new function. Other times they want you to evaluate with a given x that new function, okay? So the front page, what we're going to do is we're going to kind of reinforce it. So we're going to do both parts. A is finding the generic new function, and then B is evaluating it at a certain x value, and then the back will be going over domain of the new functions, okay? So let's just kind of revisit what we have to do. Whenever we want to find f times g of x, that is simply f of x times g of x. Okay, so maybe get in the habit of writing it like this. Spread it out. Show me what exactly you will be doing. In order to find the new product f of g, we're literally going to take f of x times g of x, all right? So what is f of x in this case? It's 7x plus 8 times g of x. What is it? 6x minus 9. So what are we going to have to do since we have a binomial times a binomial? What do we have to do in order to multiply these? Distribute, right? Some people use the word FOIL. I actually am with Gavin. I like the word distribute better because that way no matter what shape, size we have, whether it's 3 by 3 or 2 by 3, we're distributing, okay? So we're going to take 7x times 6x and 7x times negative 9 first, okay? So what's 7x times 6x? You got it, 42x squared. What's 7x times negative 9? And negative 63x, perfect. What is, now we're done, right? We've distributed the 7x. So now we're going to move on to the 8. What is 8 times the 6x? 48x, perfect. And then what is 8 times the 9? Negative 72. Beautiful. After you guys distribute, gather like terms if you can. You won't always be able to gather like terms, but in this case we are. Do you guys see the two middle terms have x's that we can combine? So in your calculator, you can just put negative 63 plus 48 and see what you get. So f times g of x is 42x squared minus 15x minus 72. So that is the desired function, or however they word it. You know, calculate or evaluate the desired function. We just found it. So what we took was we took a line times a line. And what did we get? A parabola. It's kind of interesting. So part B just says, now that you have f times g, evaluate what f times g of negative 2 is. So what are we going to do with negative 2, guys? Just throw it in there, okay? So f times g of negative 2 just means plug it into our new function. So 42 times negative 2 squared minus 15 times negative 2 minus 72. At that point, guys, as long as you're putting parentheses where we write them, MyMathLab will know like the correct order of operation. Not MyMathLab, gosh, sorry, you can see where my mind is. Your calculator will know the correct order of operations, when to include negatives and so forth. So if you throw it into your calculator, I believe I got a positive 126. So I see Corey's doing it. Corey, let me know if you get the same thing. Does that look good? Okay. So that's what we're going to be doing. We're going to be finding the generic. So if they just say find the new function, that means find it with just x's in there and leave it alone. But if they say evaluate the new function at the given x value, that means, well, find it first, right? So we had to find it first and then plug it in. One thing you can do, which I know Shia was doing, was you can actually plug, if you wanted to, another way. Like if they didn't ask us for part A, and they just wanted us to do part B, you actually can put negative 2 in here, get a value for f, put negative 2 in here, get a value for g, and then multiply the two, and you'll get the same number. So whether you find the function first and then evaluate, or evaluate, and then multiply, you're going to get the same answer. All right, 2 is going to be very similar. It's actually one that we did yesterday, or it's on our worksheets or something, but I changed it to a subtraction problem. So f minus g of x is just the same thing as f of x minus g of x. So this is the one where you just have to be careful because of the subtraction symbol, okay? So we're going to take 16 minus x squared, but we're going to subtract 4 minus x. So I, on all of them, initially put parentheses around them. So like even notice up there I put parentheses, good, so I knew to distribute. Here, this first chunk of parentheses is not really needed, but here we have to make sure we distribute the negative to both parts there. So I'll just make note of that we're going to negative. All right, so we're going to have 16 minus x squared minus 4 plus x. Does that look right? So at that point, guys, typically when you're ordering, when you're gathering like terms and stuff, it's nice. It's not 100% wrong if you don't, but it's nice to start putting them in order, like the squared, the x, the constant, right? You don't have to. So I look at the negative x squared and ask myself, is there anything else that can go with the negative x squared? No. So he's going to stay negative x squared. And then I look at the x and ask myself, is there anybody that can go with the x? No. So he's going to stay an x. But then notice the 16 and the negative 4 are like terms. What's 16 minus 4? 12. So that's what's kind of interesting. If you take a parabola minus a line, you get a new parabola. So part B is just saying, okay, now that you have that new parabola, that new function, tell me what that value would be if you put 3 in. So this is to be careful. When I put 3 in, he is only squared, not the negative, right? Because I don't have a negative, like a parentheses around it. So when I want f minus g of 3, it's going to be negative 3 squared like that, right? I'm just plugging the 3 in for the x, not the negative's not part of it, right? He just hangs out on the outside. Plus 3 plus 12. So that is going to be a negative 9 versus a positive 9. Does that end up being 6? Because the negative will hang out, you square 3, you get 9. So negative 9 plus 3 gets you to negative 6. And then negative 6 plus 12 gets you to a positive 6. So you guys just found the new function evaluated at 3. Last one, guys, number 3 is just the division. When it comes to calculating the new function, it's the easiest one because we are just going to write one over the other. So f of g of x is f of x over g of x. So we're going to take x squared minus 36 all over 2x plus 3. And you're done. So it says find f divided by g of x.
And that's that.
That's that, right? So the division one's the easiest when it comes to coming up with a new function. He's the complicated one, though, when it comes up to finding the new domain, okay? Because we don't want the denominator to equal 0, all right? So the last thing we want to do is we want to take f divided by g of 0. Meaning anywhere you see x in this function, we're going to be putting 0. So we'll have 0 squared minus 36 over 2 times 0 plus 3. So we'll have negative 36 over 3 or negative 12. Does that look right for those that?
Yeah.
I kind of just did it quick, but. Does this make you feel a little bit more comfortable? You see what we're doing? I think doing, like, writing the first initial part kind of helps me. Like, instead of keeping it, like, squished, I spread it out. I say, okay, f divided by g is f of x divided by g of x. What is f of x? Put it there, and so forth. Like, even up here, what's f minus g? It's take your f of x and subtract your second function, g of x. Sometimes they'll do it with each other, like g of x times g of x. That's fine. Sometimes it works out kind of neat. So on the back, what I did was I picked what I believe are the 3 hardest domain ones. So if you look at the back, it's now that you know what we're doing, how do you come up with your new domains, all right? So if you refer to our notes from yesterday, it says your domains for plus, minus, and multiplication are where the 2 domains intersect. So it's where f and g have the same numbers, okay? And most of the things we saw yesterday were just all real numbers. I picked 3 specifically that are not all real numbers, all right? So let's look at this first one. So we are going to find the domain of f. We're going to find the domain of g of x. And then we're going to look at those 2 and say, okay, what do they share? What do they have in common? So I'm not going to even worry about finding the new thing, f plus g. I'm not. I just want to know the domain. And I can find the domain by simply looking at the domain of F, the domain of G, and seeing what X values they share. Okay? So looking at F, what kind of function is F? It's just a line. So what's the domain of a line? All real numbers, right? Think about a line visually. It goes up and over, or down and over, forever and ever. There's no restrictions on what we can plug in for X. So the domain of F, which is just a line, right, is negative infinity to positive infinity. Are you okay with that? So like, I think I was talking to Shai about it. Any polynomial, so whether it's a line, a quadratic, a third power, a fourth power, a fifth power, all those polynomials, you can plug any kind of X value in. Positive, negative, big, small. There's no restrictions. Where do we see restrictions? 2 spots. One when we have an even root, and one when we have a denominator. Okay? So what is the domain of G of X? Well, what do we always have to take the square root of? It must be what? Not even, it must be positive, right? When it's an even root, right? If it's an odd root, like if it's a cube root, we can take a cube root of a negative or a positive. So what's that mean? It means you steal the inside, x plus 4, and make it greater than or equal to 0. So what's the inside has to be greater than or equal to 0 for it to work out. But then you solve the inequality just like you solve an equation, right? We're going to subtract the 4 over. So we need x values that are what? Greater or equal to negative 4. So how do you show that domain as an interval? We need x values that are bigger or less than negative 4. So who's our lower cap? Negative 4. And what are we moving on to? Infinity. Okay? So we did not see one like this yesterday in our notes. So how do we take this knowledge, the domain of F being all real numbers, and the domain of G being from negative 4 to infinity, and apply it to find our new domain for F of G? F plus G, excuse me. So our new domain, the domain of F plus G is going to be what? It's where these two share or intersect, right? Well, what do you know about negative infinity to infinity? He covers everyone, right? But does G cover everyone? No, G only covers what? Negative 4 to infinity. So what do they share? Negative 4 to infinity, okay? And you can kind of almost think of it as a number line if you needed to. Like, I'm just going to sketch it real quickly, guys. F, what would we shade? We would shade the whole number line, right? So for F, I almost need 2 colors. So let F be red. I'm shading the whole number line. Is that okay? That's my domain for F. But G, what is it? Just from negative 4 to infinity. So G is going to be black, and he's going just from negative 4 to infinity. So where do the two colors overlap? Negative 4 to infinity. So typically, guys, if one's all real numbers, where they intersect is the one that's not all real numbers, right? It's going to share it. So what's the domain of F plus G? Negative 4 to infinity. And we didn't have one like that yesterday, so that's why I wanted to kind of put a tougher one on here. This is going to be for you guys to keep, to take home, so when you're working on my math lab, you can kind of refer to it. So, 5. And guys, this would be the domain of F plus G, F minus G, and F times G. The only other thing that we'd have to be careful of is F divided by G, but the only difference would be this would be the bottom, and we would no longer want it to equal 0, so what would we get rid of? The equal sign, and we would make this bracket a parenthesis, and that would be the only difference, okay? So let's look at this one. We want to know the domain of F plus G, so we're going to do the same thing. What's the domain of F? Well, you just look at F and you say, well, what kind of function is F? That's just a line. What's the domain of any line? All real numbers, right? We're going to go off. We can plug any number, big or small, positive or negative. So the domain of F is just negative infinity to positive infinity. Then we got to look at the domain of G of X. Because the whole idea is we're going to see where they intersect. What's happening with G? Is he all real numbers? No. There's only one number that doesn't work. Otherwise, it's all real numbers, right? What's the one number that we don't want to put into G? 0. 0 on the bottom, which means the x value would be 8, right? So how we do it is we just say x minus 8. We don't want that to be 0, right? So we don't want x to be 8, like Gavin said, okay? So do you remember how to write that as an interval? Where basically it's all real numbers but 8, so how do we show that? Negative infinity, go to 8, right? The union, let's jump over 8 and keep going, is basically what we're saying there. All right, so how can we use these two domains to come up with our new domain for f plus g? Well, again, guys, it's going to be where they share values. What do they share? I'm going to do my number line again, okay? F was the whole number line. Yee, here we go, okay? What was G, though? Everything but 8. This is going to be kind of hard. So just write 8 there, right? And we go up to and don't include it, and then we skip over it. Do you agree that the two domains share everything but 8? I didn't shade 8, right? And so, again, when one of your domains is all real numbers, the other domain is what they share, right? Because he's going to have everything you need, right? So if he's restricted, he's going to be the shared group. So our domain will just be this guy over here. Negative infinity to 8, union 8. And I know I'm kind of skipping it because I'm not actually finding f plus g. But in order to add f plus g, you would need a common denominator. What would the common denominator be? X minus 8, right? And so you get this new function over x minus 8, and that new function still has that restriction. X cannot be 8. All right, well, look at this guy. Ooh, he's ugly. I don't even know if you see one this hard on your homework. You will definitely not see one that's weird on your test, okay? But hey, if you practice the hardest, then it makes the real stuff easier, okay? So let's find the domain of f. What do we need to remember with our square roots? They always must be positive, which means they have to be greater than or equal to 0. So with square roots, guys, you're always just going to pull what's under the square root and make it greater than or equal to 0. So let's start with f. 6 minus x must be greater or equal to 0.
Why do you have a question mark?
I don't know. I think I wanted an exclamation point. Thank you. Not a question. We know that, right? Like, are you asking us that? It's always positive. We know it. Thank you. All right, so the domain of f of x, there's two ways to solve this inequality. The math teacher in me says, hey, make it the easiest where you don't have to remember that rule of switching signs. So just add your x over to the other side. So 6 is greater than or equal to x, right? Or if you wanted to, you could subtract the 6 over, but ultimately you would divide by -1. And if you divide by a negative, what do you have to remember to do? Reverse your sign, okay? So either way you do it, you should get x is less than or equal to 6, okay? I'm going to just move the x over so I don't have to worry about negatives. So 6 is greater or equal to x, but I like writing it like this. Is that okay? So how do we show that as an interval? We want all values of x that are less than or equal to 6. So less than means we're going to the left. 6 is our upper cap. We're going to keep going on down to negative infinity, right? So the interval notation is negative infinity up to 6. Are we including 6?
Yes.
We are, right? Because we have that equal symbol, because it can be 0, right? We can take the square root of 0. What's the square root of 0? 0. We can do it. So we want a bracket there. All right. The domain of g of x, we're going to do the exact same thing, but we're going to pull x minus 1 out this time and make sure it's greater than or equal to 0. Let's make sure x minus 1 is greater or equal to 0. So I'm just going to add the 1 over. So x is greater or equal to 1. So he's actually going the other direction, right? We want all values of x that are bigger or equal to 1. So 1 is actually the low end, and then we want all the x values that are bigger, so we're going to go to positive infinity. Oh gosh, my lead's going to leave me right now, isn't it? It is. All right, so we'll have, and then that breaks, 1 to infinity. Is that okay? And we are including 1. So we're going to have a bracket there. All right, so what does that mean for our new function, the domain of f times g? Well, it's the same rules. It's what these values share or intersect. So I'm going to draw my number line. Maybe. Okay. So my number line is here. The function f is going to be red. So I want 6 and lower. Here I go. But then my function g is going to be black. My function g is going to be black, and what do I want? 1 and greater. So of the entire number line, what numbers do f and g share?
1 to infinity.
The values between what? What two numbers? Between 1 and 6. Do you guys agree? Like, because what we're doing is like 6 is going on forever, right? Yeah. So there's no red outside this direction, and there's no black outside of that direction. It's just between 1 and 6. Both 1 and 6 are included, aren't they? So we have the bracket 1 to 6. And you guys just found the new domain of f times g, f minus g, f plus g. The only difference if we want to do f over g was if this was in the denominator, it could not equal 0, so we would get rid of this equal sign here, and it would be strictly x minus 1 is strictly greater than 0, so the 1 would just be an open parenthesis, and that's the only difference.